Yes guys, so question number now 13 and 14. What is question number 13 say? Let me check it. Now question number 13 is what is given to us. Let me find out. And after that I'll solve it. Find the ratio of the volumes of a cube to that of the sphere which will fit inside the cube. Okay, so a sphere is fit inside the cube. We have to find out what is the ratio of the volumes of a cube to that of the sphere. Okay, the volumes ratio we have to find out, where the sphere is fit inside the cube. It says, what it says, find the ratio of the volumes of a cube to that of the sphere which will fit inside the cube. Okay, so inside the cube there is a sphere. Inside the cube there is a sphere here. Okay, that means the sphere will, inside the sphere will touch the midpoint of the sides of the sphere. The midpoint, now this is the base here, this base, okay, and in this way the sphere will touch. It means the diameter of the sphere will be what? The diameter will be the side of the height of this. Why? Because if I draw a sphere like this in a room, then it will pass through the midpoint of the sphere. So that is the distance of the side of the cube. Okay, side of the cube will represent the diameter of the sphere. Find the ratio of the volumes of a cube to that of the sphere which will fit inside the cube. Okay, let us take what is given to us. A sphere which fits inside the cube. To find, what we have to find out here, we have to find out here that what is the ratio of there. Now to find a sphere which fits inside the cube, to find here ratio of their volumes. To find the ratio of the volumes, first is cube, I think, and the ratio of the volumes of a cube to that of the, so cube, ratio of the volumes, that is of cube, volume of cube. Let me write here volume of cube to volume of sphere. Volume of sphere. That is the required thing. Now solution here. Check. Because now sphere is fitted inside the cube. That means the sphere is touching the middle point of each wall of that cube. Each wall, middle point. That means from that point to midpoint to the other opposite side or opposite wall of the cube will give us the distance or the side of the cube. The side of the cube will represent the diameter of the sphere. Okay, so let us take the side of the cube be x units. Okay, and the diameter of the sphere, is equal to x, the side of the cube, okay, that means this is the diameter. Therefore radius of the sphere is equal to x upon 2 units. This is units here. Alright, so radius is x upon 2 of the sphere. Therefore ratio of the volumes can be calculated. What is the volume of the sphere? X cube. Therefore now volumes of the sphere, let us find out. Therefore, solution here we are calculating. Therefore, ratio of the volumes is equal to, that means volume of the cube. Volume of the cube, first let me find out, divided by volume of the sphere. Okay, what is the volume of the cube? We know about side cube, so length, breadth and height all are same. So that means this is equal to x cube divided by 4 by 3 pi into r cube, volume of the sphere. But r cube is x upon 2 whole cube. So it will give us 3. Let me write again. This is x cube divided by 4 pi means 22 upon 3 into 7 in the denominator into x upon 2 means x cube upon 8. Okay, so this 8, this will be x cube cancel out. So 8 into 3 into 7 will come in the numerator divided by 4 into 22. 4 into 22 will come in the denominator. This one, and this 8 and 3 and 7 will come in the numerator. Now we can cancel out 4 2s are 8, 2 11 times. So this is 21:11. Hence ratio of the volumes, therefore, which is equal to 21:11. This is the ratio of the volumes. Volume of cube, this is cube, is to volume of sphere. Volume of cube is to volume to sphere of a sphere is equal to 21:11 or 20 is to, this is 20 is to, let me write 20 is to 11. Finally, this is equal to 21 is to 11. This is the answer. Okay. Question number 13 we have completed. Okay. This is how question number 13 is completed. Now let me talk about question number 14, which is the last question. Now question number 14. Let us talk about. Okay. First, before that, let me clean this. Let me clean the board. Okay. Now let us check question number 14, the last one. What are the last questions here? Let me first check it. Now it says, what is question number 14? Let me write here given. First let me read it and then write to given, and what we have to find out, prove that the curved surface area of a sphere, we have to prove here that curved surface area of a sphere and that of a cylinder which circumscribes the sphere is the same. Okay. Now this says that prove that the curved surface area, okay, curved surface area of the sphere and that of the cylinder which circumscribes the sphere. Let me now draw a sphere. This is the sphere here. Now it says that there is a cylinder which circumscribes completely outside. This is the outside cylinder. Now this is the cylinder here. Okay, so what is the radius of the, this is the diameter of the sphere. So height of the cylinder and the radius is just equal to the radius of the sphere. Okay, if I take capital R, let me take, now this is capital R here, radius, this is capital R here, and this is twice R because this is diameter, so this is twice R. If I take diameter twice R, the radius is R and R. The radius of the sphere is also R, this is R here, and radius of the cylinder is also R, and height of the cylinder is equal to the diameter of the sphere. This is the point what is given to us. We are given a sphere and a cylinder, where cylinder circumscribed, where the cylinder circumscribed the, where cylinder circumscribed the sphere, to find here. Now what we will find out, what we will find out here, let me write, what we will find out here. To find out here the ratio, to prove that, to prove here, not find, but to prove here that surface area or curved surface area, of the sphere is equal to curved surface area of the cylinder. Curved surface area of the cylinder is different from total surface area of the cylinder. Okay, but curved surface area of a sphere is only one. Curved surface area of the cylinder. Okay, so what is surface? We have to prove this. Now solution. Let us find. So here, what we will find, the radius. Let R be the radius, capital R. Let R be the radius. Let R be the radius of the sphere. Which will also be the radius of the cylinder. Same thing. It will also be radius of the cylinder, and the height of the cylinder. Height of the cylinder, because cylinders circumscribe the sphere, so height of the cylinder will be equal to the diameter of the sphere, diameter of the sphere. This we have to just understand. Okay, now let us take the final view of this. So therefore surface area, now let me find out. Therefore curved surface area or surface area in this case, solution we are finding out. Therefore surface area, let me find out first. Surface area of the sphere is equal to how much? 4 into pi into r square. This is the first equation. This is surface area or curved surface area of the sphere. This is the one only. Only unique formula is there. Now, what about curved surface area of the cylinder? Now, curved surface area of the cylinder we know that this is 2 pi r, the circumference of the cylinder, circumference of the base into height. So this is equal to 2 pi into r into h. Here small r is, that means 2 into pi r means radius is same r, since r is equal to capital R, radius is same as that of the sphere. So this is capital R into h is twice capital R, but h is twice r. So this is 4 into pi into r square. This is 4 into pi into the 4 into capital R square. The same thing is coming. This is equation number 2. Second equation, from first equation we see that surface area of the sphere and curved surface area of the cylinder both are same, 4 pi r square, 4 pi r square. Same thing. Hence from first and second both are same, which we have to prove. Okay, so we have proved this. Hence from first and second we can say, hence from first and the second we have that surface area of the sphere is equal to curved surface area of the cylinder. Now try to understand curved surface area of the cylinder and total surface area of the cylinder. Both are different. Here we have to find out curved surface area of the cylinder. The curved surface area and total surface area of the sphere is the same, but curved surface area and total surface area of the cylinder are different. Try to understand. That point I have clarified number of times, but in this case only the curved surface area of the cylinder we have to find out, in which we have just proved that they are same of the cylinder. Hence proved from first and second 4 pi r square we have proved. Hence proved. Only this we have to prove here. So question number 14 we have completed, guys. Okay, then see you in the next lecture series, which will be based on, now sphere and hemisphere are completed. Now we will take first term pyramid and prism, okay, and first term of a cone, right? Those kind of questions. One lecture series I have taken. Why? Because first term and prism and pyramids, these questions are coming very few in number. Very less questions or very few questions are coming. Sometimes there is no question, but sometimes 1 or 2 questions are there. In most of the competitive examinations I have seen very few number of questions are coming based on prism, pyramid, first term of a cone, first term of a pyramid, etc. Okay, so those things, those kind of questions are, they take some questions, 15 or 16 questions only based on prism, pyramid and first term of a cone, etc. Okay, so those that lecture series of mine is the next one. So please see you in the next lecture series. Okay, see my next lecture series, in which I will clarify what is the first term prism formulae are used, questions based on them, because already I have explained that what is first term prism and pyramid, everything. But now I will take questions based on prism, pyramid, first term of a cone, etc. Okay, see you then in the next lecture series. Bye.